Well, thank you for the introduction and good afternoon, everybody. As noted, I'm the ESNet and LBL co-PI on this project along with Dr. Jen Shope from Indiana University. And we're going to be talking a little bit about the Engagement and Performance Operations Center today. And depending on the mood and who pronounces it, it is either EPOC or EPIC, depending on who says it first. I normally call it EPIC, and then, if somebody else comes up to me and says EPOC, I normally don't correct them. It took a long time to get that acronym in place, let me tell you. So what is this? This is a joint project between Indiana and ESNet, along with our other co-PI, Dave Gent. And it is part of the CC STAR program that has been funded for a couple of years now. And the goal of this is that we wanted to try to build a little bit of a performance and operations center that was focused on working with the regional, the infrastructure partners, and science communities, because we have a lot of infrastructure that's in place to accommodate the base needs of science, whether it be from computing or networking or things like that. But there wasn't a lot of sociology. There wasn't a lot of communication that was occurring between the end users and those that were providing the infrastructure. So we wanted to focus on that aspect of it. And really, this should not be a surprise to anybody, but science is a collaborative science these days, and it involves multiple partners, multiple data sets, many different points of coordination, connection, and cooperation. And all of these things, whenever you sort of munge them together, have a way of getting a little bit confused, and this is where problems start to arise. So we wanted to have a coordination point where we can have better access to these sorts of problems, and we can ask harder questions now that we have access to all this technology underneath. So we wanted to change the way that people are doing science by working with them directly to try to fix some of the problems that they're reporting as they come up. And what does it come down to? It comes down to understanding where the hard end-to-end performance problems really exist. And this is also no surprise. Whenever you have lots of pieces in any of these large systems, whether it be from the software that the user is using to the workflow that they've tried to develop for themselves over the years to the location of where the data may exist and where it needs to be processed and stored, all of these different things, when combined together, just makes it rather challenging whenever some little tiny problem may exist. Nobody controls all these different pieces, and everybody has a different sort of expectation of what is really good, quote unquote good, for what they're trying to do. Soft failures are numerous and also very, very hard to find, and it's frustrating sometimes to figure out who to talk to about these things. We hear it often. If somebody reports that they're having a problem moving data from A to B, who do you contact? Who owns that problem? So we wanted to be there to sort of simplify with that long chain of things that are going to be going on. And just one example here of a potential area of conflict. Let's say that we're trying to move data from Indiana University to a location that's over in Thailand. If we just look at this end-to-end picture here, we're dealing with 7 different domains. We're dealing with 200 milliseconds of latency. And if there's a problem somewhere in the middle of that path, who do you go to help you fix that problem? Do you start at the ends? Do you start in the middle? Who wants to own that? And who's going to chase it to ground as it may migrate around and may eventually be ultimately different problems in the end-to-end path? So to scale this, we need partners. And that's one of the sort of core tenets of this grant, is that we wanted to involve these different organizations that are often linked together through these scientific initiatives, but they don't really have a lot of coordination points between them. So we're looking to the regional networking partners, including CENIC and some others. We're looking at infrastructure partners, providers of big resources, whether it be in scientific instrument or storage or computing, anything that really could be considered infrastructure that is there to support the scientific activities. And then the science communities themselves. You can call these virtual organizations, you can call them science community partners, but they are significant groups of application and domain scientists that are banding together to accomplish likewise goals. And what we noticed is that for these 3 different things, they all have different colors of money, but they're all really looking to sort of get to the same end goal, which is supporting scientific innovation as best as they possibly can. So we wanted to facilitate this by sharing knowledge and lessons between these different communities. So for this grant, we needed a starting point, and what I'm going to say for the next 3 slides is that I'm going to list out a couple of our sets of partners, but the important thing to note here is that this is sort of our starting point. It's not our end point. We fully anticipate scaling this beyond our initial list of infrastructure partners and regional partners, but this is where we started. So our initial 6 regional networks that we partnered with were Indiana, Ohio, Kimber, the Great Plains Network, Learn, and the Front Range Gigapop. And these are the regionals that we're going to be most tightly integrated with to start on some of these initiatives, but we fully anticipate by the end of the grant bringing in others that are interested in working with us as well. Same goes for our initial infrastructure partners. We needed to start somewhere, so we picked a couple of computing centers and consortiums that are working with researchers that are doing things right now, including Exceed and CARC and CCOE, the Science Gateways Community Institute, as well as Internet2 and the Quilt. And then a couple of science community partners. And what we were sort of targeting with these were the science communities that didn't necessarily have a lot of inboard knowledge of networking and compute and storage and all those other things. We wanted to help people that didn't necessarily have that stuff in-house because they're the ones that really need it the most. So we looked at ESIP, we looked at the ICNWG, we looked at some astronomy communities as well as precision health initiatives. And what we hope to learn from these initial interactions with these communities is that a lot of the lessons that are going to apply to them are going to be scalable to others as well. Beyond that, we do have some related coordination efforts, including coordination with a lot of other CC Star funded institutions and people, particularly the CI engineering community and others that have received the award over the years. So we try to leverage that community to sort of push out some of these lessons learned. And just a little bit of a plug, since I run this group as well, is that we do various weekly talks on a lot of these things, whether it be new research projects or ways to fix problems. It's an open group. You can just go to that little Google link right there, and I'm sure that when the slides are posted, it's a lot easier than trying to type all that in. You can sign up for the mailing list, and then we're going to be starting up some weekly conversations on 2 p.m. Eastern time on Fridays in the next couple of weeks here. And we have about 500 people that are on that list right now. So like I said, this is a starting point, not a destination. And we do anticipate working a lot closely with our other federal partners, especially the Department of Energy and some others as well. What I do want to get across here is that no one's going to be turned away. We have a lot of ongoing issues right now that people have come up to us and say, hey, we need help. And they're not from our core set of partners. They're just from the greater R&E networking community. And we try to help them as much as we physically can. So let's get into the nuts and bolts. What are the 5 sort of main focus areas that EPIC is looking to do over the course of this grant? And I'm going to go through these in a little bit of detail. And of course, if people have questions, just stop me. I can answer them either now or at the end. We've tried to focus on these 5 things because we think that they're the most useful for these different science communities, as well as the engineering communities that support them. The first is what we've called Roadside Assistance, and this is just helping people solve a problem, whether it be I'm having trouble getting data from here to here, or they want consultation on how a network should be designed, whatever the case may be. We sort of treat this as the potpourri category because we do get a lot of interesting and odd questions, but we spend as much time as we can trying to help people with that. The second part is what we've termed application deep dives, and this is really looking at science drivers and how it integrates in with the technology that is used to support them. And I'll give a little bit of information on that when we get to that section. The third is network analysis, and I think that this is probably the most important thing because unless you can measure what's going on within your communities, you don't necessarily know how well it's doing or how you can improve it. So this is really an underpinning item that is required before you can even learn more about your science. Number 4 is what we've termed services in a box, which is making a lot of these technology items a little bit more achievable for some of the smaller institutions that may be under-resourced and underclassed. And then lastly, just a general sort of statement on training, the things that people can use to be productive. So I'll go through each of these. The first I wanted to talk about was Roadside Assistance. And I was lamenting to somebody earlier that this has become, I think, the biggest focus of our grant so far, and there's a lot of pent-up demand that's out there. And whether it be something as innocuous as my file transfers were working fine last week, but now they're not, or it's, hey, I got to do this redesign of my network. Can you help me? Can you look at some of these options with me? Or just, how do I do X? I have a problem. I don't know even where to start. Can you help me? We're getting a lot of these sort of reports that are coming in, and there's a lot of demand out there. People have these questions and they have nowhere else to turn. So what did we do? We basically just set up a general email list to accept these things. That's the first step here. And think of this just like you would with any other sort of roadside assistance category. When you have a problem, who do you call? You call AAA, right? We can be the AAA of when it comes to trying to solve problems with networking and computing within this community, and we've had a lot of demand so far. This is a combination of 3 teams that were doing this already, but they were sort of focused on different communities. The first was my group at ESNet, which was our engagement group. International Networks at IU has been doing this within the international space for a couple of years. And then there was also the IRNC NOC engagement team that was located at IU. So our first step was that we sort of combined our efforts and we set up a mechanism to sort of track this and offer this as a service to the community. Anybody could submit. We have a lot of people who are NSF funded. We have a lot of people who aren't. Whatever it is, within 24 hours, you will get an email answer back, and there'll be some initial investigation to verify this issue. The most important thing, and I think the more valuable selling item for this, is that you will deal with a person. You're not going to deal with an automated system. You're not going to deal with a litany of people. It's one person. That is your case manager. And that case manager is going to give you updates as frequently as you want them. You want an update once a week, we can do that. You want an update once a day, we can probably do that too, although most people don't want that level of engagement. We have a shareable infrastructure that's set up, including whatever report you open or whatever problem we're trying to chase down. There is a public folder where all the materials that we build as we're trying to fix this problem for you are going to be thrown into there. So you can get an update, look in there, and see what's going on. I think a lot of what we found with these ticket-based systems is that they're for engineers. They're not for the scientists and the researchers that are actually doing this. And if you give them a ticket interface, it frustrates them because there's all this communication and it's in technical jargon, and we want to get away from that. We want to be able to offer the most relevant information about where that problem stands at any given point in time so that somebody can just look it up and see where it is. And the regular updates are an important part of that because you don't want to be sitting in the airport not knowing how delayed your flight is. You'd like to kind of get some periodic updates and be able to look at the board and say, all right, I'm still leaving here in about 2 hours. And that is very important from building up the relationship perspective with the scientific users. The other sort of piece that's rather frustrating, especially for the end users, that whenever you're trying to solve these things, especially if it's a long end-to-end problem that may involve many different domains, is that local experts on both sides are pulled in early, but then there's all this stuff in the middle that you don't necessarily know what's going on here. So that's why we wanted to have that folder available and why, a single ticketing system is not going to be open to everybody, and it makes it a little bit more challenging to share this. And I already talked to that, so I'll skip that slide. The other sort of thing here is that we don't necessarily want to show everybody how the sausage is made, right? So we will fix as much of the problem as we can, and if you want that information, we'll reveal it to you. We will coordinate with the engineering staffs along the path because most times the scientists don't necessarily care why the problem is broken. They just want to have it fixed. And we're cognizant of that. We want to make sure that we are the ones that are handling whatever they want to see. And if they don't want to see that piece of information, it doesn't need to be revealed to them. But what we will do is that we will keep that ticket open until the reporter is satisfied with the result. The ticket does not get closed just because we cannot make any more progress on it. We will ask them, do you want this open or closed? And that usually results in, the metric of how many tickets you've solved in a month is not really that useful anymore. We're going to have a lot of open tickets that have been open for a very long time, but we're making progress on each one. And when we finally do get to the point where we can close out a ticket, the last step before we officially close it out is that we write it up. And we try to write it up in a way that can be posted to a public forum, in this case, Faster Data, or just about anywhere else, so that when somebody else runs into this issue down the road, there's some documentation trail that is available so that they can go out and try to do something with that. The other emerging piece that we sort of got out of this is it isn't just about, hey, fix my problem. It's also consulting. And this is a little bit lighter weight than what a full roadside assistance would look like, but the process is going to be the same under the hood. Contact our list, and whatever problem you're having or whatever questions you have, we'll try to answer. And these do get answered rather quickly in case we need to do additional engagement going into the future. But we wanted to approach it from the same exact perspective of it being an operations center approach, and results and suggestions for whatever they're attempting to do will be documented so that we can share those lessons out. So a couple of really quick examples of this. One of our first problems that was reported to us was an issue with the Pan-STARRS telescope that was located in Hawaii. And I wasn't directly involved in this, so I will have to do a little bit of slide reading here. But they regularly did some large data transfers between Hawaii and a location on the mainland. In this case, it was at Johns Hopkins University in Maryland. And, for 100 terabyte data transfer, if you're only going at about 320 megabit per second speeds, it's going to take a long time. So, where do you go from this, right? When you're on a really, really long end-to-end path, which originates at the actual telescope itself, and it leaves the Hawaiian network and goes across the Trans-Pacific Cable and lands in California, and then gets transferred to Internet 2, and then eventually to Max and to the Johns Hopkins, there's a lot of moving parts that are involved in this. And, having somebody sit in the middle and try to coordinate it is a very valuable thing. Because who would you report this problem to initially? If you reported it to ESNet, we'd probably, say, well, you're not directly connected to us. Who are you directly connected to? And anybody in that chain of command could have been the same way. So how did we get to the actual problem solution stage? Using perf-sonar testing to identify that, there was not a full 10 gig connection through. And then also using perf-sonar again to identify another problem later in the path. And this is a rather common thing. It may not be one problem, it may be several problems. And then fixing a couple of other things, including MTU settings and TC buffer settings. So at the end of the day, 5 problems at UH, an underpowered top-of-rack switch as well, and then some aging software systems. So I'll correct myself one more time. 6 problems identified just in this one item here. And then what do you get at the end of the day? Well, you go from 320 to 1 gig, which is still pretty good when you're going that far away. And some other actions that we couldn't necessarily fix at the time, but are there to be fixed in the future when more funding becomes available. Additional architecture and software issues that are being worked on. And then I do have one more example here because I think that you can never really have enough of these things. This was an LHC data movement issue between Pakistan and the UK. Again, this isn't even in the US. This is something that came to us, but we still tried to help it as much as we can. And this was between a Tier 1 and a Tier 2 site. And this was at the National Center for Physics in Pakistan, and trying to get to information or sending information to Queen Mary University in London. Transfer rates as low as 40 megabits per second. So again, really abysmal performance. You can certainly know that something is wrong if you're getting that low of performance. So there were a lot of issues that were identified in this one as well. First and foremost, you probably discover that there is a real network problem, like a traffic shaper that was misconfigured. There was also a little bit of an issue of splitting the research and education traffic away from the commodity traffic. There was a top-of-rack switch bottleneck. There was some intermittent packet loss within the campus. There was intermittent packet loss outside of the campus. There were more bottlenecks in the path, So again, we're looking at about 6 or 7 layered issues here that one person is never going to discover on their own. And the outcome here is that you go from 40 to 480, and you may think, well, that's not great, but it's 10 times better than it was before, which is a lot more than they would have got if they were trying to debug this on their own. So that's just sort of a quick little taste of where we go with the roadside assistance, and helping people fix problems is very important and very fulfilling. But we have a couple of other pieces to this center as well. And the next item is the application deep dives. And this comes from an observation that, you can have somebody come out and fix the car when it breaks, but you also have to do regular maintenance on your vehicle as well. And the concept is based on something that Eli Dart, sitting in the audience there and paying somewhat attention started years ago for ESNet, which was doing scientific case studies. And what does that mean? That means do an actual walkthrough with a scientist or a scientific group to understand what they're actually doing on technology. And we're not going to stop at just network. There's also a piece that involves computing and storage and all that other great stuff as well. But this helps the network provider, in this case ESNet, understand a little bit more about how we can plan and be able to support them more in the future. But it also gives the scientist a little bit better idea of what's going on out there with their peers and ways that they can try to improve their workflow overall. And really, this is not about trying to improve networks or computer storage. This is everything to do with sociology. And it's building relationships and trying to figure out what people are doing and why they're doing it. So the anatomy of our deep dives really have two components. It's a narrative and it's a data estimation. And we have templates that are based on the ESNet version of this that are online right now. We haven't fully published the EPOC versions of this, but we will be doing soon. But these templates are really meant to guide you through this process of answering questions about what you're doing and why you're doing it. So first you walk through the scientific components, background information, the name of the facility and the science that is being done, but then digging a little bit deeper into the specific components that are going to be different on a science by science basis. Who are you collaborating with? Where are they physically located? Identify people, institution names, locations. What sort of instrument or data collection are we really looking at here? How much is it producing? Where does it produce it? How often does it produce it? Where does it need to go after it's done? And then really the process of science, which is a narrative. You can think of this as a day in the life of what happens for the people who are doing the science in that group. And we have done a couple of these live over the years, and I think my favorite was doing one with a beamline operator at LBL. And what I figured out is that the process of science for them is a lot of rolling around between workstations because that's what they do. They do a sample, they get some pictures of the sample, they do some processing of the sample, they may take more pictures of it. And this involves just a lot of transmission back and forth on their feet and on their chair between these different resources. And when you look at these things, you can make suggestions about how they can improve their sociology and how they can improve their process just by observing it. And this is things that they would have never really thought about because, hey, they're busy doing their science. There's a couple of other technical aspects that you try to ask, but you try to avoid giving that question directly. You never go up to somebody and say, how much network do you need? That's not a useful question for anybody to ever have to answer because the answer invariably is all of it. Give me all of the network. We want to understand what they're doing. So we ask questions about, hey, what software are you using? How do you interact with it? Do you use a workflow monitor? Oh, you don't know what that is? Let's forget that I asked what a workflow monitor is. Are you using networks and data architectures within, or are you renting them from somebody? Are you using cloud services? Those sorts of things. And then lastly, sort of the airing of grievances at the end where you're trying to understand what the outstanding issues and pain points are. Local and regional IT staff are critical for these particular questions, and you try to bring them in where you can. So when this is all done, you hopefully have a better understanding of what the science data movement, who's using what pieces, all the different dependencies and timeframes are for a specific group or a specific campus or maybe even a specific region. And the goal here is to sort of produce a small report. And that report is useful for a number of different things. Perhaps if you're going for a future NSF grant, now you've identified scientific drivers. If you are trying to plan campus upgrades or regional upgrades, you have actual data that you could go back and point to and say, look, well, that scientist said that a couple years ago. Maybe we should plan for that because it's going to be coming up pretty soon. But it also builds these relationships between the layers. You want the engineering staff to be talking to the science staff as well as the administration in this. You're all partners together, and you don't want this to be some sort of turf war. You want to all be working towards a clear path towards improvement and success. So the third component here is network analysis. And really what we mean by this is that performance measurement is useful for sort of two real reasons, right? It's useful for the first thing that we were talking about with roadside assistance in that I want to understand if there's a problem out there and I want to be able to have infrastructure to go out and solve said problem. But I also want to understand what's going on. And the only way to understand what's going on is to measure it. And unless we have infrastructure in place to measure it, it becomes a random walk and guessing What kind of stuff is going on? Well, I have no idea. I don't have any instrumentation. So we can do this with existing tools like Personar, or portal applications like myes.net. The one that we focused on, because it's a sister project to EPOC, is NetSage. And what this does is it tries to combine the intelligence from a couple of different sources, in this case SNMP, Personar, NetFlow, SFlow, TStat, a bunch of different things together, and offer you an analytics platform that allows you to understand what's going on. So I would encourage you to go to portal.netsage.global. That's deployed right now. There's a bunch of different views in this, but I'm just going to highlight one really, really fast. And here's an example of how you can get a little bit more information about what's going on about a happenstance. So in this case, a day in the life of one particular circuit here between the United States and the EU. One morning, you notice that circuit is a lot hotter than it used to be. All right, well, what's going on? You can dig in a little bit deeper with the available graphs and the available charts and things like that, and you'll notice that, yeah, there's a lot more traffic on that. What's going on? Going in and looking at the pairwise listing of flows gives us a little bit more information here. We see that there's a couple of LHC sites that are the top senders by volume and by rate. And, what does that mean? That means that all of a sudden, experimentation on this particular link really ramped up. The end result of this actually was there was a load balancing activity that was going on between these links, so it absorbed a lot more scientific flow from LHC traffic. But until you can really dig down a little bit deeper and understand what the elephant flows are looking like and why they're going there, we wouldn't have figured out why all of a sudden that utilization spiked. So there's a couple of key questions that NetSage is trying to answer. The first is just a simple, how used are links and where are congestion points via looking at bandwidth information. But the other, and I think the more interesting use cases, are related to the flow data and the data archive monitoring that you get out of TStat. What are the top sites using links? What are the top sources and destinations? Or some emerging work that we just started doing, we're instrumenting data transfer resources at a couple of supercomputer centers. What are the top sources and destination pairs? And do any of those top source to destination pairs have any problems in their transmissions? So let me explain a little bit more about that one. Here's a very hard to read graph from one of the data archives. I think this is the one that's located at TAC, one of the Exceed sites. And we instrumented their intake nodes. And this is where people, if they are transferring data into TAC, they have to hit these data ingress machines right here. And you can look that in a typical day, there's a lot of volume that's coming in from any of these different sites. Los Alamos, Texas Tech, SDSC, University of Minnesota. Another little thing that's not shown here is that we're also recording what retransmissions look like. So if we happen to see a site that has a pretty large data flow, but an alarming number of retransmissions, that may be something that we want to go and investigate a little bit further to understand, hey, is there a problem on that network path between you and them? Could your performance be a little bit better? These are all important and useful questions to sort of look at. A system like this, when coupled with sort of your scientific deep dives, helps you understand who's using your network and why they're using it. Otherwise, it's just a random walk. So the expectation here is that the regional partners will be deploying NetSage within the course of our grant here, and we're doing a lot of engagement with them to get that step up and running. And then the infrastructure partners are going to be the next ones right behind. So we're targeting the NSF and DOE supercomputer centers, or anybody else really for that matter. We have this sort of simplified down to a pretty easy to do software package. And then after that, you get sort of a customized dashboard view so that you can see what's going on. All right, so that pivots us into sort of number 4 here, which is the services in a box piece. And what do I mean by services in a box? For those of you that know, we did a series of workshops years ago called the OIN workshop, and these were successful. We had about 750 people go through 30 workshops. And, before I patting myself on the back over that, there's a lot of interest in stuff like this, but I think the one thing that used to bother me the most about it is I'd have really great conversations with people and they'd be like, oh, this is a really great workshop. I'm never going to use anything that you've told me. And I would say, okay, well, tell me why you're not going to use anything that you've told me. Well, I'm from a small institution. I'm the IT guy. I got to go home and change projector bulbs. I got to go and fix Windows laptops. And, there's only so many hours in the day. So as great as Perf Sonar and Science DMZ are, I'm not going to use that. But thanks for teaching this workshop. That was really fun. A lot of people have interest in technologies and they can see the value, but when you're trying to convince somebody that they need to adopt this on their campus, they're going to run into these barriers. What are the intermediate use or the immediate use cases? How much is this going to cost me in terms of time and money? And why do I have to design and specify and build it? That's really hard. Why would I ever use something like that? So what we wanted to do with this was to bring the barrier a little bit closer to success. Large facilities with dedicated funding can afford to do this. They can afford to spend time designing and tweaking and upgrading and trying to find all these different use cases for these science technologies. But the smaller ones will never do such a thing. So we'd like to ameliorate the cost of the design and install at a higher level. And in this case, it's going to be our regional partners or our infrastructure partners, and then create infrastructure that can be delivered as a service. We want the operation to be either local or regional. There's some flexibility there, but more importantly, develop a better business model here that can facilitate cost recovery and upgrade schedules, because you just can't build it once and then it lasts forever. Things are going to break. So this is sort of our more experimental piece of this grant. We're going to try to offer a way for these traditionally smaller and less resource facilities to have a taste of this stuff, to see if it would be useful to them. Create new paths for regionals to interact with and learn about these different scientific use cases, because again, if you don't have a scientific use case, it doesn't make a whole lot of sense to invest time in this. And then reduce costs for the service deployments and the operation. I want to turn sort of well, I can't do that, or I'm not interested in doing that, into, all right, now I see why this is useful. I can give this to this researcher, even though he's not a huge fish. Oop. I don't know how many I skipped there, but I think that's where I was. So our audience here is that we are sort of working this from both sides of the equation. We're talking with the deployers, which are going to be the regional networks and the laboratories and the infrastructure partners, but we're also working with the users as well. We want to understand if they have a use case that can really take advantage of these things. So we're assuming that the following is true. Limited IT staff and budget, interest in these things, but not a critical 24/7, 365 need for them. We're going to start small. We're going to look at measuring and monitoring, usually with things like Perf Sonar and with NetSage that I've already discussed. But then also, what does this look like in terms of a data transmission service? You probably have irregular bulk data movement that is occurring on your campus right now. We'd like to understand that a little bit more. Maybe there's a way that this can be implemented in such a way that people can get a lot of value out of it. We are making some assumptions here about the locality of where regional providers are going to have equipment, because to get a lot of these things, you are going to need to make an investment in physical infrastructure. But we want to take away the step of hardware specification, because that is time consuming. And at the end of the day, it all sort of looks the same from a hardware perspective. It's really how it's implemented and how people learn how to use it. So just really quick and crudely drawn pictures of what this may look like, for monitoring. It could be as simple as having monitor locations at each of the sites and then pulling all the data back centrally. For something like a data transfer capability, we want to encourage people to try to either use a shared resource that may be deployed at the region, or it may even be positioned on their campus. But a lot of this, and it all goes back to those deep dives that I mentioned earlier, it's all sociology. It's working with the user to understand what their workflow looks like, so that you just don't install something that nobody will ever use. You need to understand what their process looks like. So we do anticipate doing this for Perf Sonar and for Science DMZ and data transfer nodes and all those other things. This is probably the most further out of our project at this point. We anticipate working with our regional partners in probably the next year and a half to get a lot of these out there. And lastly, the training component here. And like I said, this is a follow-on to OAN, but we don't want to just be doing, here's how you set up a DMZ or here's how you set up Perf Sonar. We want to go a little bit deeper here and encourage people to take some of the lessons that we've learned over the years. In particular, the application deep dive component that we're already going to be doing with regionals and universities, we want to teach people how to do that. That's a lot more useful from a scalability perspective, because if we know the right questions to ask, we can fix a lot of these problems at the core, and we don't need to always be going and reinventing the wheel each year. We will still do technical training upon request. In fact, we have a couple of these scheduled throughout the year. A lot of them are going to be posted to our website, but we do want to move more into the how you use it versus why I should design it that way piece. So that's all that I had, and I'll leave this slide up as I answer any questions that come in. Our main email address there is epoc@iu.edu. We have our web presence, and then those are the PIs. So I will turn it back over to the audience in case there are any questions. One question in the back. Do we have a mobile microphone here? I will give it to whoever wants to be the runner. So I think there was a question back there.
Well, yeah, that's on. Okay, cool. So I was curious, are you talking with industry partners right now? Because we're seeing both data flows to other institutions, but we're also seeing people asking about best performance ways of getting data into insert cloud provider name here. So, and both in and out. So they're kind of reaching the same level where it's like, it's nice to be able to have the measurement infrastructure and the context there. So is there any communication happening like in scope of this project with them?
Mm-hmm. So perfect timing on that question. And I didn't put it into our slides here, but we as EPOC are not directly doing a lot of the engagement with cloud providers, but I know that there are many that are. So what we've been trying to do is accumulate a lot of the lessons that people are learning in this space. You know, for example, the Persona project, you know, another sister project that's developing monitoring software, has been engaging with a couple of cloud providers on that exact question that you asked. You know, what's the performance characteristic in and out of that cloud? Can we have some sort of permanent resource that is available so that we can test in and out? Understanding a little bit more about that. So we want to be the coordination party for this and a documentation party instead of one that's physically doing that work. So we do intend to publish as much as we can glean about that particular area.
Jason, so you brought up two examples of problems you solved, two scenarios. Both were, I think, high bandwidth, high delay product paths. And it sounded like there were many issues that got resolved in both of those. Is that indicative? Is that normally the case in your engagements, that you're seeing multiple problems across the path versus a single broken piece of hardware or even software on the end system?
Yep, every single time. It's never just one. It's usually three or more. And often it's not the network. It's the host systems, it's the software, or it's, you know, it's a lot of different contributing factors that go into that, but it's never just one.
It's always the other guy, not me.
Clearly, it's always somebody else's problem, right?
So on the same topic, all the various things that were wrong, was there, like, did some of them give you like 90% of the bandwidth you end up recovering and some just 10? Like, was there like the biggest bang for the buck problem that you solved, or was it each one gave you another little bit?
Yeah, so that's a great question too, Dana. And the way that, you know, TCP dynamics work, and I can see Eli is ready to stand up on a chair and swing his mace around his head on this one, is that no, it doesn't really work that way. You know, the problems all mask each other, right? And when you're dealing with, you know, the long latency, long path, high bandwidth thing, all of them combined together, of course, make it really, really crappy. But even if you only fix one or two, you'll see incremental improvements. But it isn't until you get to the very end and get all six of them that you finally get up to an acceptable level. I mean, there's rarely mediocre performance. It's really either really, really bad or it's really, really good. unless you're dealing with, local distances, and then it's usually okay.
Well, I have a question, and it sort of follows this theme. How, as somebody who provides, research IT services, I usually get tasked by people who are highly motivated. But how do you approach a situation where there's asymmetric motivation? You've got a server somewhere that's just kind of sitting there and it's got some data on it, and you have a researcher on the other end who really needs to get that data, but there's nobody on the other end of that line. And, how would you figure out an approach? How do you solve that issue? Who do you talk to? What would you do in that case, Jason?
Mm-hmm. So this is a frequent issue as well. And, I can answer with a pure economical argument is that incentives matter, right? So you have to incentivize everybody to really want to solve this problem. And, public shaming works very well to a certain extent too, because if you can really identify something down to two parties and be able to point out to them, look, this is the area that I need you to investigate, and motivate them enough that it's not going to take them very long to investigate it. And at the end of the day, you'll probably walk away with, fixing this issue. That's usually the best course of action. And we had another one that I haven't documented here, but I remember it well. It was an issue where after 3 months of debugging on their own, they just couldn't solve this nut. They finally came up to us and said, look, we've tried everything else. Obi-Wan Kenobi, you're our only hope. Can you please just sit down with us and we can try to figure this out? And the problem ended up being in a location that they went over several times before, but it's almost always in the demarcation zone between two parties where both people point at each other and say, well, it's his fault, right? And because they're looking at it as a demarcation point, it's not my problem. So you have to incentivize everybody to really come to the table and work towards that common goal. And people will respond in different ways. But I think that if you can isolate it down to a single issue, then you get more people will be interested in trying to kick it over the goal line there. I'm at 0 minutes, but I think Mark has a question.
Yeah, it's kind of it's now a 3-part question, but I'll be really quick. So addressing what you just talked about is that it's sometimes the concatenation, and the test local is good, the test wide area is good, and it's only when you glue them together that there's a problem, and that sometimes is the indication of that demarc. I was also going to comment on the roadside assistance examples. Didn't seem like those were blown tires. Those seemed like things that we just hadn't gotten our car up going fast enough yet. And so instead of it was working okay and then it stopped working, this is one where it's not working up to my expectations. I don't expect you to comment on that. That was just more of a reflection. The piece that I wanted your feedback on was it seems like the 24-hour triage and the way things are set up may not scale real well if you have a whole lot of people that are interested in the assistance.
I like that observation, and when I have that problem, I'll come back to you and say it's a problem. But at this point, we have not quite scaled to that limit. We're still going to make that promise.
Great.
Make it hard on me, Mark.
Well, Jason, I just want to thank you so much. It was a fabulous presentation, and I know everybody in here appreciates it as well. So thank you.
Thank you.